So we're going to talk about what to do when we have multiple steps to take when solving a problem, meaning we have to use the multiplication and the addition properties of equality, not just one or the other. So the first example that we're going to look at is x over 2 plus 3 equals 5. So what we're going to do to solve this is I have multiple things to think of. My goal is still to try and get x by itself, which means that I need to take a look at what's on the same side of x, right? So I have x divided by 2 plus 3 on one side of the equal sign, so that's what I'm working with. What I would get rid of first is the addition or subtraction, right? When you're combining or you're simplifying something, you always go back to PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, and that's the order that you do things in. Well, when you're solving, you kind of do a reverse PEMDAS. You want to add or subtract before you multiply or divide when you're trying to solve for a variable. So I see this addition, so that's what I'm going to deal with first. To move that, I'm going to subtract 3 from both sides. These are going to cancel. On this side, I'm still left with x over 2, and on this side, 5 minus 3 is 2. Now, to get rid of this division, I have to multiply both sides of the equation by 2, so that the division and multiplication cancel out, and I'm left with x on this side. On the other side, 2 times 2, that's going to be 4. So, by using kind of a reverse PEMDAS, by adding or subtracting before we multiply or divide, we can solve for x fairly easily. Our next example is going to be 2x minus 3 equals 5. Or equals 9, I'm sorry. Now again, I'm still trying to solve for x, meaning I'm still trying to get it by itself. I'm going to look at what's on the same side as x, the 2 and the negative 3. Well, again, I want to get rid of addition or subtraction before I get rid of multiplication or division. So I'm going to try and get rid of this 3 before I get rid of the 2. To get rid of the 3, I'm going to add 3 to both sides. The 3's are going to cancel out. On this side, I'm still left with 2x. The other side, I have a 6, plus. I have 12. Now to solve for x, I'm going to get rid of this 2 by dividing both sides of the equation by 2. These are going to cancel, and I have x equals 6. Now again, if you wanted to check your answer, you could take x equals 6 and plug it back in to your original equation and see if the sides end up equaling each other. Remember, if you're plugging something in, it's very helpful to put it inside parentheses. So now we just use PEMDAS. We multiply before we add or subtract. 2 times 6 is 12. We're going to subtract 3 from that, and it should equal 9. 2 minus 3 is 9. The sides equal each other. That's accurate. So this is our solution, x equals 6. Okay, we're going to look at one more example. We have 2 over 3 x minus 4 equals 6. Fractions, right? So what we're going to do is try and make everything as simple as possible, okay? So obviously, 3 is the only denominator that we have. If we're trying to solve for x, I would again worry about getting rid of addition or subtraction first. So what we're going to do is we're going to add 4 to both sides. So those are going to cancel. On this side, I still have the 2 over 3x. And it's going to equal 6 plus 4 is going to be 10. Now I just have to get rid of the fraction, and I'm going to do it in 2 steps. First, I'm going to get rid of the denominator by multiplying both sides by 3. When I do that, The 3's are going to cancel. I'm left with 2x equals 10 times 3 is 30. Then to get x by itself, I would divide both sides by 2. On this side, they cancel out, and I have x equals 15. X equals 15 is the answer to 2 over 3x minus 4 equals 6.